Hi, welcome to your flip video for 6.3. 6.3 is titled percents greater than 100. So these are percents that are more than 100%. So like the example we saw in class today, I always give 110%. You can have percents greater than 100. And most people say you can't, but that's because they fundamentally don't understand what a percent is. Percents that you typically see on tests, like 72%, 93%, 55%, those are percents that are less than 100, and people feel more comfortable with those. When you start talking about percents more than 100, they get uncomfortable because they fundamentally don't understand what a percent means and how you represent it. So let's start there. Let's break down percent. So at the beginning of the year, when we did part equals percent times whole, and I'm going to come back to that later, we defined what a percent is. So a lot of people say a percent means out of 100, right? Per out of cent, 100, out of 100. And this is very, 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 very not right. It actually is for every 100, and that makes a lot more sense because you could have 200%, and that just means that you have 200 for every 100. So for every 100 allows us to have more than 100 as a percent, so like 110%, but it also allows us to have negative percents because then you could have, we talked about negative growth. If something, gets shorter over time, so a plant dies and starts getting shorter, it can grow negatively, which is the same thing as shrinking, but you can have negative percents if you phrase it as a percent means for every 100 and not out of every 100, because if you can only have 100 to work with, you can't go more or less than 100 or 0 respectively. So 213% just means you have 213 for every 100. 923% just means you have 923 out of every 100. And you can simplify these into decimal form. That's something we've been working on. So 213 divided by 100, when you divide by 100, you take that decimal point and move it 2 to the left because it's getting smaller by a factor of 100. So 213 divided by 100 is 2.13. 923, there's your decimal point, 1, 2, scoot it over, so 9.23. If you ever go in your calculator and you had, let's say, 75% on a test, and there were 100 questions, you got 75 out of 100 right, well, 75 out of 100 is probably what you'd see on the top of your test. So you'd go into your calculator, and you would type in, 75 divided by 100. Oop, that's not a division sign. 75 divided by 100, which is the same thing as 75 over 100, right? Fractions and division are the same thing. And your calculator would tell you 0.75, but you didn't get 0.75%. You got to change that into your percentage, so you multiply it by 100, and you actually got a 75%. This was an easy example because if you had 75 questions right out of 100, it's easily 75 out of 100. But if you had 23 out of 25, and you will go to your calculator and you type that in, your calculator would tell you 0.92. Well, you didn't get 0.92%. You got 0.92 out of 1. So this is like if you scaled your fraction down. How do you go from 25 to 1? You divide it by 25. So if you do it to your denominator, you do it to your numerator. 23 divided by 25, that's what you typed into your calculator, is 92. So you got 92 out of 1, but percent means out of 100. So if I'm trying to get that denominator to be 100, and multiply by 100, because 1 times 100 is 100, 92 times 100 is 92, 0.92 times 100 is 92, so you actually had a 92%. That was what you scored on your assessment, okay? So it's the same idea here. 923% is 923 divided by 100, or 9.23. These are all interwoven with each other. So a couple of quick, easy problems. 200% of 1 is blank. So let's convert this English sentence into math sentence. 200% just means 200%. Of means multiplication. 1 is just 1. Is means equals. So this is 200% times 1 is blank, equals blank. And now we have to convert 200% to a decimal. 200% means 200 over 100 because there's 200 for every 100. And 200 divided by 100 just gives me 2.00. So really this is saying 2.00 or 2 times 1 is equal to blank. 2 times 1 is 2. So 200% of 1 is just 2. 125% of 18 really means 1.25, so I'm going to skip that step of converting it because you just saw it. If you need to refresh, you can pause right here and look through how I went 200% to do 125. 125% is 1.25 of means multiplication. I threw in those little steps right there for you. 18 is 18, is means equals, so 1.25 times 18, 22.5. And that makes sense. 125% is a little bit more than 100%, and 100% of 18 is 18, so I would expect my answer to be a little bit higher than 18. I'd expect it to be 25% higher than 18. What's 18 times 0.25? Well, that's 18 over 1. 0.25 as a fraction is 1 over 4. 18 divided by 4. Well, what's 18 divided by 4? You get 4 and 2/4, so 4.5. So if 25% of 18 is 25% is 4.5, and 100% of 18 is 18, 4.5 plus 18 is equal to 22.5, right? Because doesn't that make sense? 25%, I'll do this in a different color. 25% plus 100% of something should give me 125% of that thing. So we can break it up, just like we've been doing in other problems. When we had mixed numbers, 3 and 2/5 is a terminating or non-terminating decimal. We could do this as 3.0, and 2/5 is 0.4, so 3.0 plus 0.4 is 3.4. So 3 and 2/5 must equal 3.4, and 3.4 is a terminating decimal because there's nothing after that 4. So 3 and 2/5 must also be a terminating decimal. We can do the same idea with percentages. 100% plus 25% is 125%. So you can break it up, and that makes doing the mental math a little bit easier. All right. We're going to tie this back into something we worked on. I want to say this was topic 3, but I'm not 100% sure. Part equals percent times whole. All right? This is nothing new. You've already worked with this. This was a pretty easy subject for you guys. And this was rate of change. So what is 130% of 18? So what's your part, what's your whole, what's your percent? Well, percent is pretty clear. 130% has to be your percent of 800. Let's break this down into words. So that's going to be my whole. So blank, I'll represent with the box, is means equals. 130% is my percent of means multiplication. 800 would be my whole. So how do I know 800 is my whole? Because of this phrase right here where it says 130% of 800 of means multiplication. So I'm doing a percent times a number. Where do you have a percent times a number? Well, right over here, percent times a whole. So my 800 must be my whole. And that also makes sense because if you have 800 as your starting point, you have 800 and you want to take 130% of that 800, well, you have 800 to start with, so that starting point would be your whole. So what in this scenario represents your part? So part equals percent times whole, or part equals 1.3, because 130% is 1.3 times 800. 1.3 times 800, 1,040. All right? Now, we have a little word problem here. During a harvest, the yield is 5,010% of the previous year. Last year, this farmer, so same farmer with the 5,010%, this farmer produced 412 pounds of corn. How much did he make this year? So let's break this down. You have some important information here. The yield is 510% of the previous year. You made 412 pounds of corn last year. How much did you make this year? Well, what I want to know is my amount this year, I know I had 510% of last year, so that 412 is my starting point from last year, so that makes it my whole. 5,010% is my percent, because percent is percent. And now I can just convert percent to a decimal, multiply, and get my yield for this year. So my yield for this year, my part equals 50.10, and I just took that decimal point and I shot it over twice, because you do that to make a percent into a decimal. So 50.10 times 412, I have 20,641.2 pounds of corn this year. Now, something that some of you struggle with is, what if you're given the part and not the whole? So in other words, if you have the part equals percent times whole, you struggle if this is a number and this is a number and this is a variable. So let's look at that example. So same data from the last question, 510% increase, or 510% of the previous years. This year, you made 8,000%. So how much did you make last year? Well, I need to know my starting point in order to compare it to this year's. So this becomes, highlight my important information, 8,000, because I have 8,000 pounds, is equal to 510% times last year. And I'm going to represent last year with a C for corn, because I'm not creative. Well, we could say C is for creative then. Okay, so I've already converted that 5,010% into decimal, 50.10. So 8,000 is how much I have this year, and I'm going to set that equal to 5,010% times last year's produce. So how do I get C by itself? Well, let's label. I'll label percent. My part is 8,000 because that's what is a result of the 510% of the previous year. So that would make last year's my whole. So how do you get C by itself? You divide both sides by 50.10. These guys cancel out. Whoops. These guys cancel out, because 50.1 divided by 50.1 gives me 1 over 1, and you would not need to write 1C divided by 1. That's redundant. This is equal to C. So this is equal to just C. So I get C is equal to 8,000 divided by 50.1. 8,000 divided by 50.1 is 159.68, and we can go ahead and check our answer by plugging it back in. So we can do 159.68, I'm running out of room here, times 50.1, and if I get the same number as what I started with, this 80,000, I'll know I've gotten it right, so I'll go to my calculator, type that in. Lo and behold, it's roughly 80,000. I had to cut off a couple of decimals from the 159, this 0.68. This keeps going a little bit farther, but it's right around 80,000. So I know I did it right. So you can always go back and plug in the variable that you had into your equation and see if you got it right. All right, that's the end of 6.3. You guys are moving right along through this. Let me know if you have any questions.